Okay, so here we have another set of problems that we are going to be working on today, which is how to simplify radicals. A radical is simply a number that is being square rooted. For example, the square root of 30 is the same thing as saying what is radical 30. Or another example, the square root of 36 is asking what is the radical of 36, okay? Now, how do we do such a thing? We do these in a simple fashion, a simple manner. We simply check to see if the number is a perfect square. For example, this is a perfect square. And we know the square root of 36 can either be positive 6, which is what we want in most cases, or negative 6. So here we say plus or minus 6. Why? Because 6 times 6 equals 36, or negative 6 times negative 6 equals 36. Because you multiply the same number and itself to get 36, then that number will be a square root. So there are two square roots. We have positive 6 and we have negative 6. All right. Now, square root of 30. If we were to find square root of 30, we'd have a little bit more of a challenge, because the rule for simplifying a square root is for us to find a smaller number that is a perfect square that can go into 30. And the fact of the matter is that there's no smaller number that's a perfect square that can go into 30. The perfect squares that are below 30 that could potentially go into 30 are 25, which can't, 16, which can't, 9, which can't, 4, which can't, and 1, which can, but dividing 30 by 1 still gives 30, so it becomes redundant. So our final answer would still be radical 30. And that's how you do something like that. If you wanted to do something like the radical of, let us say, 72, we look for a number, a perfect square that can go into 72. In this case, we have 36. The largest number that can go into 72 is 36. The largest perfect square, that is. So we separate the one radical 72, into two numbers, 36 times radical 2. And we find out radical 36, and it works out to be 6. So our final answer will be 6 radical 2. Usually that is what they want. Yeah, and so that is our answer. Another one that might seem challenging if they give you the radical of 45. Radical of 45 is going to be found by simply finding a factor of 45 that's a perfect square. In this case, 9 times 5. Radical of 9 is 3, so we get 3. Radical 5 is our final answer. These are basically straightforward, nothing too difficult with them. Moving on from this, we're going to try to find some algebraic equations that deal with radicals. For example, if you have 3 plus radical 2x equals, let us say, 75. What we'll do here is try to isolate radical 2x on one side. I made a mistake. Isolate radical 2x on the left side. And in order for you to do that, you must subtract 3 from both sides, okay? So you'd subtract 3 here, and you'd subtract 3 here. This is the additive inverses, which cancel out to 0, leaving you with radical 2x on this side equals 72 on this side. So we have successfully isolated the radical term on one side. Now, how do we get to x? I want you to think of the radical symbol, this radical, as being, I want you to think of this as being a parenthesis. Think of it like a parenthesis, right? And think of it further, that the opposite of square root, which is what this is is the square. So the opposite of square root, the opposite of square root is squaring, okay? And vice versa. So here we have radical 2x, which when I say radical, I mean square root. So let's rewrite the problem. We have radical 2x or square root 2x equals 72. We're going to perform the opposite action. The opposite of square rooting something is to square it. They cancel each other out. So we are going to square this and we are going to square this, okay? When you square, the square root cancels the square, leaving you with this cancels this, leaving you with 2x equals 72 squared. We keep 72 squared as it is, or we can write it as 72 times 72 because that is what the square term means. This here, beside and to the right, upper right of a number means 72 times 72. So we keep it like that. I always tell the students to keep the factors 72 and 72 separate because if you were to multiply it out, you'd get a large number. Students are generally afraid of large numbers. We keep it that way because we want to eventually divide at the bottom. Divide by 2 here and divide by 2 here. And we end up with this cancelling out, leaving you with x equals 72 times 72 over 2. Now, we have no other choice but to work things out. And we can do that by using the GCF of something on the top and something on the bottom to cancel. So we are going to use 2 divided by 2 cancels out to give 1. And once we do the same thing to something on the top, we are still in the right. 72 divided by 2 is 36. So we are left with 36 times 72 over 1. And obviously, to get our actual answer, we are going to have to do the multiplication. There's no avoiding it now. See, we have delayed it until the very end. And of course, we do that using this technique. We say 6 times 2, we get 12. Put 2, carry 1, 6 sevens, 42 and 1, 43. Then we do 3 times 2, which is 6. You put a 0 as a placeholder. We do 3 times 7, 21. Put 1 here, put 2 here. Keep everything in order. And then we add. We get 2, 9, 5, 2. And so our final answer is 2592. That is the value of x. Answer, x equals 2592. Seems huge. We can also check it if we like in the original. Let's do a check. Check. We are going to insert or substitute 2592 into the original problem. The original problem is 3 plus 2 radical 2x equals 75. We're going to check if we get a true statement. 3 plus radical 2x equals 75. Let us see that. We are going to keep writing both sides coming down, right? To see if we eventually are going to get a true statement. Let's see how that pans out. Let's change it into green. I like bright colors. They represent the ebullient spirit that I have. So we're going to insert 2592 into the equation. So we have 3 plus square root of 2 times 2592 equals 75. And we are going to work the left side. We're going to put 3 plus. And when you work out 2 times 2592, you keep a section for rough work here. Rough work. We're going to do 2592 times 2. 2 times 2. 2 times 2 gives 4. 2 times 9 is 18, put 8, carry 1. 2 times 5 is 10, plus 1, 11, put 1, carry 1. 2 times 2 is 4, plus 1 is 5. So we end up with 5184. So we end up with 3 plus radical of 5184 equals 75. We keep going down. We find square root of 5184. And if you like, you can use a calculator. And you will see that the square root of 5184 is 72. So we end up with 3 plus 72 equals 75. Keep bringing it down. Work this out on the left. We get 75 equals 75. And that is true. So we know what we did was correct. That is how we do these kinds of problems. Yeah, thank you.